EFIS installation. In 2004, Greg and Todd got together, started making the Horizon systems. The EFIS systems take care of all your flight instrumentation, your navigation, provided you have a GPS hooked up to it, moving map, terrain, engine displays as long as you have the EIS, and also with all the new ADS-B stuff or XM weather, you can show your weather, traffic, and our navigation database for the EFIS systems that's on the website effectively has all the information that you'd ever be able to find in the green book, the airport facility directory. All that stuff is in there. So if you need something as you're on a cross-country flight, you need to know what the frequency is for a weather frequency at ABC Airport. All you got to do is select that on the map, hit the details, and it'll run you right to it, give you all the information that you need on that. Frequencies, runway size, how long it's going to take you to get there, if there's lights or not, and what services are available at that particular airport. And then also if you have one of those ADS-B systems installed in the airplane, if there is weather information for that airport, it'll give it right there on that details screen. Basic schematic for the HX, actually the WSHS, HX or HXR, you've got the display unit, you've got the AHRS, and you've got the magnetometer. You can have any combination of those up to 5 different screens, 2 AHRS, and if you have 2 AHRS, you'd have 2 magnetometers to go with those. Every time that you add another screen, it gets a little bit more complicated, as you can probably guess. For pure redundancy's sake, if you have 2 AHRS, the AHRS output information, which includes your pitot-static information and your attitude indications, you want to wire that directly to every single screen that you can. Because if one AHRS fails and a screen fails, if you only wire it direct to 1 and to 1, if you have AHRS number 1 and display unit number 2 fail, you may lose the ability to show your attitude information if you just run it 1 and 1. By doing the crossover that you see there in pink, you can lose either one of the screens and either one of the AHRS, and you won't lose any functionality as far as attitude, airspeed, or anything else goes. Any questions on that?
How would you know when an AHRS fails? I mean, does it have a fault indication?
Yeah, normally in a dual AHRS situation, you'll be running on the dual AHRS. If one of them fails, it'll switch to AHRS number 2, and it'll tell you in the top right-hand corner of the display, on the primary flight display, it'll change from the words dual AHRS to AHRS 1. And then you can start troubleshooting and figure out what happened. So the Sport and the Mini, those are a little bit more basic. The Sport, it's just the display unit which has the internal AHRS and then the magnetometer. And with the Mini, provided it's the Mini X that you or AP that you have the magnetometer for, it's wired the same way. There's an external magnetometer. With the Mini B, there is no external mag, so it's just the display unit, and that's all you need. AHRS mounting consideration, this is where people start getting into trouble when they start putting these things in. With the standard AHRS for the HX, HXR systems, leveling them with the lateral axis of the airplane, wingtip to wingtip, is important. We don't have a way in the system to adjust for tilt of the AHRS in lateral direction. Long axis, same thing. Nose to tail, you want to have it in line with the airplane. Depending on the airplane, if you've got a velocity that you're trying to put it into, I don't think there is a straight line on that airplane anywhere. So you don't have a lot to follow. You got to kind of work at it to get it straight. Whereas if you're putting it into an RV, the longerons, as they go through the cabin, are pretty well straight, and you can get yourself a nice straight reference to get it lined up with. The thing that doesn't make much of a difference is the pitch attitude of the AHRS box. We have an adjustment for that called the pitch ladder offset in the set menu as you do the programming, that if you have it lined up with the airframe and you're a tail dragger, you want it to be in level attitude when you're in flight, not when you're on the ground. So we can adjust for that in the setup. The one thing that I've seen a lot of lately is that people are putting the magnetometers in the wrong direction, putting the connectors facing forward. In the AHRs of any of our system that has the separate AHRs, both the AHRs and the magnetometer connectors should be pointed towards the rear of the airplane. Easily the biggest problem that anybody has, that we hear of anybody with installation issues of the AHR system in the airplane, is magnetic issues. The magnetometer is really nothing more than an incredibly sensitive magnetic compass. And the closer you are to anything steel, especially anything steel that moves, the more error that you're going to be inducing into the indication, which in turn is going to affect everything else. Things like bell cranks for the ailerons and elevators, aileron counterweights, everybody, stainless steel rudder cables, stainless steel shoulder belt cables. They're stainless steel, yes, but there's still a lot of magnetic steel in there. It's not pure stainless steel. So we find a lot that people put their magnetometers mounted up in the just behind the baggage compartment in an RV, up on the ceiling, or in between the longer runs. And when you do that, the shoulder cables for the shoulder belts on an RV, they have a stainless steel extension that runs back to the longer run. Well, every time you lean forward or lean back or shift your shoulders, that moves. And that little bit of magnetism that's there and is only 6 to 8 inches away from the magnetometer will affect the magnetic field readings that it sees, and then it will affect your magnetic heading indication. Guys with slider type canopies on RVs, when they go to do their magnetometer calibration, when they're down in the south, a lot of times they'll go down and do it when it's hot. They'll leave the canopy open. Well, if they mount their magnetometer up in that same spot, the steel frame of the canopy will affect it. And then they'll close the canopy, that magnetism is gone, so the calibration that they did for the canopy open doesn't equal what they do with the canopy closed. So then you end up with a magnetic heading that's off. Yeah?
Wingtip, is that a good location, even if there's a bomb archer or VOR in there?
The wingtip is the best place in an RV, and in most airplanes to put it. It's got the least amount of steel. In an RV, it's the aileron counterweight, that steel pipe on the front side of the aileron. That's really the closest thing. The Archer antennas, because they're made out of aluminum and plastic, they're not going to make any effect on them. Especially if they're you just use them as a VOR antenna, that's receive only. So it's not going to make any difference. The wires themselves that run in between the magnetometer and the AHRs, it's signals that are going across there, so very, very seldom are they affected by other current carrying wires, unless you've got them going directly across and they're laying pretty much right on them. Running strobe light wires out to wingtips or nav light wires out to wingtips, landing light wires, things like that, we don't see that they have a very big effect on the wires themselves. Now, when you get that wire out to the wingtip, and we had one of these installations a little while ago, he had put his magnetometer on the wingtip, and his conduit with all of his wires came out right above it. So he had his strobe light wires and nav light wires laying right on top of the magnetometer as they came out. And every time he turned his strobe lights on, his magnetic compass would start to spin. He took that thing and moved it forward and got the magnetometer out away from those wires. And it only took him about 6 inches to do it. But just having the wires laying across the top of it was causing the problem. Once he got it out from underneath there was no change at all. Avionics connections to the different Horizon systems, each one of them has a serial port. In the sport systems, there's 4 or 5, depending on which one of the sports you have. In the HXs and HXRs, there's 8 serial ports. They have a in and an out. You can put the in and out to different things as long as the rate, the baud rate that they are connected with is the same for both of those pieces of equipment. So you can be talking to an autopilot on the output, and you can be listening to a GPS from a handheld GPS that you're feeding into the system. all on the same serial port, but as long as it has to be on the same baud rate so that they talk at the same speed. On all the GRT systems, we use a USB connection in order to update software and also to connect to a variety of different ADSB systems, XM weathers, things like that. Also to do data recording. On the sports systems, there's one. On the minis, there's a mini USB on the minis. On the sports, there's one, and on the HXs and HXRs, there are 2 USB ports to use. With the HXs, HXRs, you can use the georeference charts and demo recording everything else. One thing is that it's not the same as a computer where you can have multiple USB sticks plugged into it at the same time. This is a closed source unit, so we can only take a maximum of 1 USB stick per unit, which is fine with the minis and the sports because they only have the 1 port. But with the HXs, when you're doing multiple installations, if you have the georeference charts on 1 USB stick, and then you have that plugged in, and you go to update your EFIS software and plug in another USB stick, the system's not going to recognize either one of them because it doesn't know which one to look at. So you can only have 1 USB stick in the system at a time. The power inputs. The more complicated the system, the more redundancy that you want to build into your system. You want to have multiple power inputs, multiple alternators, multiple batteries. With the sport units, we have 2 inputs. With the HX, the HXRs, we have 3 power inputs. Each one of those power inputs is diode protected so that if there's power at one, the second power fails, you're not going to feed the second power through the first power input. Every power input that you have has a voltage monitoring indication, so you can have a bar graph on your engine page to watch that to make sure that they all stay up at the same time. One more thing about those, if you do have a backup power or a secondary or a third power input to the EFIS, what you want to do is you want to have them turned on all the time. Both of them. Your primary coming off your avionics bus, you want to have that one turned on, obviously, so everything works. The secondary, you want to have that turned on as well as you're doing a normal flying, whether the first one's working or not. That way, if the primary power fails, the secondary power will instantaneously pick up and take over, and you won't lose any functionality. If you have your backup power turned off and your primary power fails, then you have to recognize what happened, flip on the secondary power switch, and then you have to wait for the EFIS to boot back up again. So if you have 2 or 3 power inputs into the EFIS, you want to have them turned on all the time, regardless if something's going wrong or not. That way, a couple of different things. You can, number one, you can monitor those and make sure that the battery voltages are staying up for your multiple batteries. And if something happens, you'll already have that second power in place to take over. Any questions on the EFIS stuff? I know there's a lot more stuff out there that I didn't cover, but there's a lot that, yeah. Was there, Dennis already has it's a WS on the 7, right? Yeah, okay. He's got a Horizon system in his RV, and sometimes it takes 15 or 20 seconds for the alignment process to happen. Sometimes it takes more than 2 minutes. That can be attributed to a couple of different things, depending on what it is. There's a bunch of different ones that it could be. The first thing is movement. When the magnetometer is being aligned, just after boot up there, if the airplane, if it's a windy day with the RVs, they got those really springy gear, If the airplane's rocking from side to side, that makes it take longer because it has that slight variation in what it's seeing. It takes longer for it to align. If it's a calm day, it probably takes less time because the airplane's not bouncing around. So movement plays a big factor into that alignment timing. Direction has also something to do with it as well. If you're close to the hangar, there's a lot of steel in the hangar, and if it's to the north of you, it can make changes to that and take longer to align that way. And then there's a couple others too, but you can start getting far out in a lot of stuff. Most of the time what it is, that time change, especially with the RVs, if it's a windy day, the winds are rocking back and forth, it'll typically take longer. Anything else? Like I said, if you come up with anything else for the EIS, you'll call in, you'll probably be talking to Nick. I'm there too. If you got any EFIS questions, you'll probably be talking to me. You may also be talking to Mark if I'm already busy. And we're around from 9 until noon, and then again from 1 until 4:30 Eastern time at the shop Monday through Friday, if we're not at air shows. I guess that's about it. Thanks for coming.